VDC services can also provide for the creation of a virtual mockup. Depending on the requirements of the project or the needs of the stakeholders, the different type of BIM models can be created with different levels of development. We will talk about levels of development in the later stages of this lecture, but having a virtual mockup, it will allow us to be able to analyze more complex conditions and study about how the different parts of the assembly fit together, such as the joints and the edges between the assemblies, which will require collaboration between the multiple trades. You can see here some examples of the mockups that is needed. For example, detailed modeling of some unusual foundation components, the excavation scenarios, some unusual formwork, analysis of construction sequence alternative, virtual mockups of alternative primary structures, or the curtain wall system design. Some of these details, you can have a specialized model that is also 3D printed to allow the stakeholders to understand better the relationship between the different components, and the different parts can also be color coded to make it more easy to assemble and to be taken apart. Here you can see a virtual mockup for a paneling for the fire station project. VDC can also allow for sequencing and construction assembly simulation. During the construction phase, on-site modelers can assist the project staff with detailed analysis, quality control, validation for daily construction tasks. The geometric data, that means we are talking about maybe the length, the breadth, the height of the building component, okay, in a 3D model can be augmented with the different phases of construction and the constructability information. Examples of this type of work includes detailed modeling of formwork, scaffolding, reinforcement bars, and penetration details, as well as sequencing of the assembly. That will allow the construction site personnel to be able to run what-if scenarios for the more optimum construction sequencing, to allow for resource allocation, and to also resolve potential problems ahead of time. For larger elements, especially complex fabrication systems, it is useful to animate the delivery to ensure that there are no spatial conflicts or issues with the sequence of installation. VDC will allow the stakeholders to be able to carry out the information model quantification and cost estimating. VDC often will include BIM, and the BIM generates an accurate quantity which can be linked to the cost database. We call it the 5D model, which I'll talk about in the later part of the slides, and that allows the stakeholders to compute the cost estimate for the project. The traditional method of construction basically utilizes conventional manual calculation methods, and the people or the stakeholders will be calculating or counting elements and areas from partial drawings that rarely describe the whole complete project. And as a result, the process is very tedious and sometimes not very accurate. When we are using VDC for our project, the cost taking off will be more instantaneous, but it will only be as accurate as the accuracy of the model. So as a result, the following VDC workflow requirements will have to be undertaken by the project stakeholders. They will have to review the completeness of the model which they are using for quantity taking off. They have to ensure that the quality and the accuracy of the BIM model is acceptable. Yeah? and it is important for the estimator to know the model's level of development, which I'll be talking about later, okay, as some of the items may not be included with a model that has a lower level of development compared to a model that has a much higher level of development. This shows you a screen capture of a cost estimating software called Innovaya, and the highlighted blue load-bearing walls, they are being reviewed, okay, for the quantities and the costs. VDC allows for system coordination and interference detection. The system coordination can happen in two phases. It can happen during the design phase, where it is done by the consultants. It can also happen in the construction phase, where the subcontractors, they are coordinated, okay, for manufacturing and installation. In order for there to be a successful system coordination and interference detection, these are the following requirements. There must be clear methods and guidelines for system coordination in order to collaborate in the most effective manner. Normally what we do is that the different systems, they are modeled in a certain sequence, and the sequence are based on the importance of the different services and the flexibility of each services. Every system and subsystem is color-coded for ease of visual understanding. A comprehensive template is used to track a wide range of different interference between different types of services and components. The location of each interference is saved in a model, so it can be actively used in the resolution for each issue. Interference are also statistically recorded and broken down per trade, so the resolutions can be tracked over time. The thing to note is that as most of the subcontractors or trade modelers, they are CAD-based systems, each participant's layer standard is reviewed so that it interfaces seamlessly with the ongoing tracking of interference in the coordination model. This is an example that shows you the crash detection between the the window or the door, okay, with this structural I-beam that is interfering, okay, with the particular component. Yeah, so there is a detection of a clash between the different services and trades, and that needs to be worked out before the actual physical construction takes place. Here it shows you a diagram of the system subcontractors coordination, where you can see that the different services, they are color-coded to allow the stakeholders to know which are the services representing, yeah, and when we are doing the crash detection or the interference checking, it will be easier to call out, okay, the different parties that need to be informed to resolve the situation or the clashes. VDC services can also offer logistics and site safety modeling, where you actually model the construction site to allow for the transportation or the logistics to be done in a safe manner. You model the whole site to allow for the site safety to be taken into consideration during the day-to-day work. As an example, the New York Department of Building accepts site safety and logistic BIM model as submission instead of 2D documentation. The department provides a logistics Vivid template with preloaded components such as cranes, access arrows, staging locations, and scaffolding. So that will enable the department to be able to automate some of the reviewing and speed up the approval process. So for example, this picture shows you the BIM model that is used to take into account the provision of the scaffolding and the force work that is put up for the actual project, as well as the movement requirements of the cranes or the equipments to provide for the logistics for the project. VDC services also include 4D schedulings, and this 4D scheduling links the scheduled activities with BIM in order to visualize the sequence of the construction. That is superior over the traditional workflow where the stakeholders will need to link the geometry to the relating activities, and that will be very time consuming. Through VDC and in the BIM model, once the 4D schedule is set up, it will require very little effort to maintain the 4D BIM schedule or BIM model. In addition, when updates are made, it is easy to run comparisons with the baseline schedule so that we can spot what are the late or the early activities. For the scheduler, they will use the BIM to build up the schedule instead of just using the model to visualize the schedule. In a GIS, 4D scheduling gives visual feedback to the scheduler and the different project stakeholders. 4D scheduling makes the relationship between the different assemblies easier to understand. The objects or the components can be color-coded based on numerous criteria such as the activity type, which company, which trade, or whether they are late activities or early activities. Different versions of the schedule can also be run to compare the changes and to allow the stakeholders to plan for alternatives. And it can allow for auditing the schedule for missing activities and incorrect sequencing. This shows you a schedule from a 4D simulation starting from, for example, May to the month of August, where more these construction activities has already occurred, to the month of October, where even more work has been done, to the month of January, where the work is almost fully completed. That will allow the different stakeholders to be able to visually see how the construction should look like, for example, in the baseline case, and they can actually then take into account any changes, and compare against the baseline scenario. VDC can also be used for progress planning and tracking. The VDC tools can allow the inspector to use the model to establish the completion status for each element or component. Use the software to color code the status and report which quantities are completed. Can be used for generating reports. The model is used as a recorded document of the complete sequence of the project. In terms of tracking construction progress, it can be used to validate where a project is in relation to the construction schedule and for determining what payments can be made issued to the contractor. And this is very valuable after the construction is completed if there are any disputes about the sequential conflict. Finally, VDC can be used to control the quality of the different models. Models, data, and documents produced by the project team must be closely monitored to ensure that the coordinated data is generated for the project execution. So the 3D model operation roles, the operators' roles are to hold successful 3D coordination meetings to identify and resolve design and construction issues, and for developing project-specific tracking procedures for the management and resolution of coordinated tasks.